It says the fundamental theorem of algebra, and honestly, we've been hammering this the whole time that we've been working on solving these polynomial equations. But the fundamental theorem of algebra just tells you the number of zeros is the degree of the polynomial. So like if I give you like x cubed whatever, you can immediately tell me it's got 3 zeros. Or if I give you x squared, you immediately tell me it's got two zeros. That's the fundamental theorem of algebra. So you guys already know this. I just didn't call it that while we were going over the questions in class. Now, this is going to piggyback on what we did Friday. Whenever you have a roots of a polynomial, they can be real or imaginary. If they're imaginary, this says they always come in, and I started to write in again, pairs. If you remember from Friday, if you have an imaginary root, like a plus bi, automatically you get its conjugate. So if you ever have one imaginary root, you automatically have a second one. So they have to come in pairs. So they have to come in twos. So like 2, 4, 6, 8. If you have one imaginary root, you have 2. If you have 3, you really have 4. So they have to come in pairs. Now, real roots don't have to come in pairs. They can be individual on their own. But if you have a real root, they're going to be visible on the graph. And a real root on a graph is just going to be an x-intercept. So where the graph crosses or touches the x-axis. So imaginary you cannot see on a graph. Real you can see on the graph. Okay, now we're just going to do this first little, I'm going to make a table out of these. And I'm not going to show you a graph of the polynomial. All I'm going to do is tell you the leading term. So that'll tell you the degree. And then we're going to talk about like how could the roots appear? Would they be real? Would they be imaginary? Just based on the degree. Okay, so this says the leading term of this polynomial is 5x to the 6. So how many answers, roots, zeros, whatever you want to call them, how many would it have? If my leading term is 5x to the 6. 6. Okay, now here's the deal. I'm going to basically make a table because there's going to be different options for how this can come. I always go with the imaginary first because I know they have to come in pairs. So it's possible, if I'm going to have 6 of these zeros, it's possible that none of them are imaginary. Okay, if none of them are imaginary, how many real would I have to have? 6, okay? Does that make sense? So that would be one way that that could shake out. All right, I could have, you can't just have one imaginary root. They have to come in pairs, so I'm just going to use even numbers. I could have 2 imaginary roots. If that's the case, how many real would I have to have? 4, right? It has to add up to 6. Okay, I could have, I maybe should have spaced that a little bit better. Sorry, I'm going to have a 4th thing here. I could have 4, right? They have to come in pairs. If I had 4 imaginary zeros, how many real zeros would we have to have? 2. Each time they just across that row, they'd have to add up to 6. And then the last possibility, all 6 could be imaginary, and then you would have 0 real. So those are all the possible things that can happen. That's all I know from that because I don't know the rest of the equation or we don't have a picture of a graph. Does anybody have a question? Okay. If I tell you the leading term is negative 2x to the 5th, so it's the highest term, how many zeros would we have to have? Negative 2x to the 5th. What do we think? 5. Bless. Okay. Now, I always start with the imaginary. So, if I could have none. None. If I had no imaginary, how many real would we have to have? If we have to have 5 total, that has to be 5. Okay. Now, imaginary, they have to come in sets of 2. So, I could have 2 imaginary. How many real would we have in that case? 3. Does that make sense? Now, I could have 4 imaginary. Then how many real ones would we have to have? 1. Okay. Could I have 6 imaginary? No, because that would be too many. So those are the only 3 options that could appear for that situation. Okay. What if I had 9x to the 7th? How many zeros would that have? 7. Okay, so I always just start with the imaginary. So I could have none. How many real would I have to have in that case? 7. Okay. Imaginary have to come in pairs, so it has to be even numbers only. So I'm going to do 2. If I have 2 real, how many imaginary would we have to have? 5. Just each row would have to add up to the total number you need. In this case, it would be 7. I could have 4 imaginary. How many real would I have then? 3. Okay, I could have 6 imaginary. How many real would I have then? Could I have 8 imaginary for that situation? No, because that would be more than the total, which is 7. So that's where we would stop. Is anybody having a question? Okay, now what I'm going to give you, I'm going to give you a graph down here, and you're going to tell me how many real and how many imaginary zeros this graph has based on the degree. Okay, so each one of these graphs is a little different, but this first one says degree 7. Can you tell from the graph how many real answers this one has? Like, how would I figure that out? Go ahead. 3, definitely. Okay, so yeah, right here. And it doesn't matter what they are. I'm just where it touches or crosses the x-axis, I can see 3 real. Okay, if this is a 7th degree, how many imaginary solutions does this have then? 4. It has to add up to 7. So this would be 4 imaginary. I'm just going to kind of abbreviate that. All right, if this guy in the middle here, if this is a 4th degree, how many real zeros can you see on that graph? You could, it does actually, a couple of them are close together, but I've got 1, 2, 3, 4. So this is 4 real. All 4 of them are taken care of then on the graph, so this would be 0 imaginary. You don't have to write that, but I'm just kind of keeping that in mind. All right, my third graph, this is 5th degree. How many zeros can you see on the graph? 1. You just have 1 real. All right, so if that's degree 5, how many have to be imaginary? 4. And all of these, hopefully you're noticing this, the imaginary are coming in even. Like this would be 4, this is 0, this is 4. They can't come in odd numbers. All right, if this guy down here is degree 3, how many zeros can you see on the graph? All 3. Yep, 1, 2, 3. So this is 3 real, 0 imaginary. Okay, then my very last question, this is a 6th degree polynomial. How many real answers does that one have? Doesn't touch the x-axis. Okay, so 0 real. So then how many imaginary would we have to have? 6. All 6 would have to be imaginary. Okay, is anybody having a question?